Welcome back, guys. So in the last video, we left some topics to be discussed later, one of which is the format of a DHCP packet. So we'll be covering that today. And once that is done, we can move on to our next topic, that is static and dynamic address allocation. So let's start with our topic. All right, guys. So we'll be starting the discussion with DHCP packets format. DHCP packets format. Okay, so this is how a DHCP packet looks like. There are multiple fields involved and we'll be discussing each of these fields. Okay, so first up we have operation code, right? Now operation code, this is a 8-bit field. Okay, so this is a 8-bit field and it represents the type of message. Now there are two classifications in the type of messages. Okay, so there are two types of messages. First is request and second is response. Okay, so for request, the value of operation code is 1 and for response, the value is 2. Okay, so if you guys remember DORA process, we had discover and request. These were of request type, right? These were of request type. And other thing that we had was offer and acknowledge. These were of response type. Okay, so for response, the value for offer and acknowledge, the value would be 2. And for discover and request, the value would be 1. Okay, so this is our operation code. Next up, we have hardware type. Okay, so hardware type, let me just erase it. Yeah, so for hardware type, it defines type of physical address. Okay, so type of physical address is defined by hardware type, right? For example, if we take Ethernet, for example, for Ethernet, the value of this field would be set to 1. Okay, so this is our hardware type. This is again for 8 bits. Next up, we have hardware length. Okay, so hardware length gives the length of physical address. Okay, so MAC address length is given by our hardware length. Okay, and this length is in bytes. So let's say for Ethernet, if we take an example of Ethernet again, then the physical address for Ethernet is of 6 bytes. Okay, so 6 would be the value here. Next up, we have hop count. So hop count is number of hops a packet can make. Okay, so number of hops that are valid for a packet to make and is represented by hop count. Okay, next up we have transaction ID. Okay, so what is transaction ID? So this is, first of all, this is of 4 bytes. This is of 4 bytes. Okay, and this is for identification purposes. Identification. Okay, so client sets it to something. Client sets our transaction ID to something, right? And it is used to match request with response. Okay, so we have multiple requests and we have multiple responses, right? So we want to map one request to its corresponding response. Well, for that, we'll be using transaction ID. So the request and response would have exact same transaction IDs. Okay, and it is set by client, right? So this is covered. Moving on. Next thing that we have is number of seconds. Okay, so DHCP request is made when client first boots. Okay, first time the client boots, it sends the DHCP request. Okay, so number of second is time in seconds since client started to boot. Okay, so the time period since the client started booting, that time period is in seconds, they're stored in this field. Okay, so this is number of seconds. Next up we have flags. Okay, so number of second, it's a 16-bit field. Again, flags is also a 16-bit field. Okay, so there are 16 bits. Now 15 bits. Okay, 15 bits are all set to 0. Right? This 1 bit, this is the one that can vary. It can be either 0 or 1. Okay, so if the message, the type of message is unicast in nature, this will be 0. And if it's broadcast in nature, it will be 1. Okay, So if it's unicast, 0. If it's broadcast, 1, right? Let's clean it a bit so that we can explain further fields. Okay, next up, we have client IP address. As the name suggests, it's IP address of the client, right? Now, initially, we do not have an IP address for client, so this would be set to zeros. Okay, so it will be a string of 0, right? Now, this is your IP address. This field is also IP address of client, IP address of client, but this is set by server, set by server. Okay, so this IP address is the original client's address. So client sent that I do not have address yet, so it will send field to be 0, right? So this field would be, this field would be 0, right? Then it will reach server and server would assign some IP address to our client, right? So that IP address would be added here in your IP address. Okay, next up we have server IP address. Of course, this is IP address of our server, This is also set by server. Because if you guys can remember, client did not know about the server's IP address, right? So this IP address is also set by server. Next up, we have gateway IP address. So this is IP address of router. IP address of router. Okay, so this field is also 4 bytes. This is also 4 bytes. This is also 4 bytes, and this is also 4 bytes. Okay, so this is IP address of router. Again, this is also set by server. Set by server. Okay, next up we have client hardware address, right? Client's hardware address. This is set by client, and this gives us the machine address or the MAC address of client. Okay, next up we have server name. So this field is set by server. This field is set by server. Okay, so what information does this contain? This contains domain name of server. Okay, this gives us the domain name of server. Okay, and this field is optional in nature. That server might fill it or server might not. Depends on server's willingness, right? So this field is optional. If no name is filled in this field, then you have to make all the bits set to 0. Okay, so you have to do that. Next up, we have boot file name. So most of the information is provided in this packet, but there is some other info. Yeah, so there is some other info that is required for booting. Right? So that other info is present in some file called boot file. Okay, so some file called boot file. So here server specifies path to boot file. Okay, so path to boot file is given by server in this particular field. Okay, next up we have options. Options is of variable field. It's of variable length. Okay, so the length of the field options may vary, right? Now it has dual purposes. It can be used for two things. It has dual purpose, right? It can be used for two things. Either it can have some additional info like network mask. Okay, some additional info like network mask, or it can have vendor specific info. Okay, so there were two purposes. First is additional information like network mask or the default router's address, or it can have some vendor specific information, right? So this is our last field, which is called options. Okay, so this was our packet, and these were the fields that we discussed. So I hope this was clear. Next up, we'll be discussing address allocation. All right, so we're beginning with address allocation. We're covering address allocation, right? Okay, so the main function of DHCP server is to allocate or is to allot IP addresses to our system, right? Now that allocation can happen in one of the two ways. Either it can be static or it can be dynamic, right? We'll be understanding the difference between these two. So first of all, our DHCP server has two databases. Okay, so first database first database is called static database. Static database, right? And second database, as you guys can already guess, is known as dynamic database. Okay, so in first database, in static database, what we have is we have mapping. We have mapping of physical address to already designated or allocated IP addresses. IP addresses. Okay, so some physical address might already been designated some corresponding IP address, and mapping of those would be present in static databases, right? Static database. And next up we have dynamic, and along with dynamic, there's another thing that is a pool of available IPs. Available IP addresses. Okay, by available IP addresses, I mean that these addresses are not yet designated to anyone, and these can be used to be given to our system, right? So dynamic databases, what they are, what this is, we'll be discussing that, right? So what happens is initially we have a client, right? We have a client and we have a server, DHCP server. Okay, so client makes the request to our server to allocate some IP address. Okay, so client lacks the IP address, it's seeking for one, and it sends the request to our DHCP server. Okay, now DHCP server, we have seen the packets format just now, and we know that DHCP server would have physical address of client by now, right? Because in packet, the physical address of the client was mentioned, right? So when we get the request, we'll get the physical address of our client. Now server will send this information to our first database, to our static database, right? It will send the information to static database, right? And check if there's a mapping of this physical address. Let's say it's P1. There's a mapping of P1 to anything. It'll check. Okay. So if found, right, then what we'll do is we'll say that, okay, you have already been allocated or designated some IP address. So we are returning. So we'll just return IP address as permanent address to client. Okay, so we'll say that you've already been allocated this IP address, so take it. We're returning that to you, right? Next up, if not found, then what will happen is we will check in our pool of available IPs, right? And we'll find some IP address. Okay, so we will find some IP address, right? Now this IP address is assigned to our client. This IP address is assigned to our client, and an entry is added to our second database. In dynamic, we add the entry for this IP address. Okay. The mapping of IP address and physical address is added to our dynamic database, right? And this is sent. This IP address is sent as temporary address or temporary physical IP address to our client. Okay, so this is sent back to our client. Okay, so why I say temporary? Because that's the point of dynamic allocation. In dynamic allocation, we are giving IP addresses for some interval of time. Okay, so there's a lease. There's a word called lease. Okay, that means that for some time interval, the IP address is yours. It's yours to use. But after that time period, either you'll have to renew your lease, or let go of IP address. Okay, so either of those things are supposed to be done. Either you can renew your lease or you can let go of the IP address, right? Lease is that we are giving ownership of the IP address for some small amount of time to our client, right? So this was our static and dynamic allocation. The previous protocols that were used for our host configurations, they were of static nature, right? Now this protocol is of dynamic nature. This can also provide dynamic allocation, right? So this was our address allocation. Next up, we have error control to discuss. Okay, so we'll be discussing the last topic, that is error control. Now it's a very small topic. Okay, so error control, why do we need it? First of all, suppose our request got lost, right? It got lost during transmission or it got damaged. In either of these cases, it would not reach the server. Okay, and if the request didn't reach the server, we won't get the response, right? And we'll be waiting for infinite time just for the response to come. But since server did not get the request, it won't send the response ever, right? So to get things back on track, when there's a situation like these happen, we need error control, right? So DHCP uses UDP, and UDP does not have a separate mechanism for error control, right? So we have two strategies. If we have two strategies, using them, we can ensure that error control is accomplished, right? So our first strategy is requires UDP to use checksum. Okay, so checksum is optional in UDP. So we force UDP in DHCP, we force UDP to use the property or use the field of checksum. Okay, this is one of the strategy. The other strategy is use retransmission policy. Transmission policy. Okay, so what happens is, suppose we've sent a request and we sent some request and we did not get response. Okay, so no response has reached yet. Okay, so in that scenario, there's a probability that request got lost or it got damaged and it never reached the server. Okay, so in this strategy, what we do is we retransmit our request. Retransmit our request. Okay, and this time it will reach the server and server will send us the response. Okay, so this is the policy of retransmission. But sometimes retransmission causes traffic because multiple clients are trying to retransmit their request, right? So there'll be a lot of traffic. To avoid that, sometimes DHCP forces clients to use their timer and set it to a random number. Okay, so sometimes DHCP what it does is, since retransmission might not work every time, so in the case that there's too much traffic, so it introduces the concept of timers as well. So DHCP forces the clients to set its timer as well. Okay, so that no traffic is created. Okay, so this was error control in our DHCP. So this sums up the video. Today we discussed three things. First of all, packet format in DHCP, right? Second, we discuss address allocation in DHCP, right? And third, we discussed error control in DHCP. Okay, so these three things were discussed in this video. This sums up the topic of DHCP from my end. Next up, we'll be discussing DNS. So meet you in the next set of videos.